So let's look at example number 2 that deals with inelastic collisions. Suppose we drop a ball from a height of 10 meters and it only bounces back to a height of 7 meters. Now if the mass of our object, the ball, is 1.2 kilograms, how much energy was transformed or transferred into thermal energy? So let's look at our situation once more. Our ball, so we take a ball with a mass of 1.2 kilograms and we raise it to a height of 10 meters. And then we let it go. Our ball travels a height of 10 meters or a distance of 10 meters and then it hits the ground. And there is an inelastic collision. And that means some of the kinetic energy goes into the ground, goes into increasing the internal energy of our ground as well as the internal energy of our object, the ball. So energy is transferred into the ground as well as into the ball, and then our ball bounces back, but only bounces a distance or a height of 7 meters because some of that energy was now wasted or went into the ground as well as into our object. We want to find what that amount of energy was. The way we do it is we simply find the amount of energy at the initial condition, then we find the amount of energy at the final condition, we take the difference, and that will give us the amount of energy that went into thermal energy, that was transformed into thermal energy. So let's look at the initial system. So how much energy is at the initial system when the object that is 1.2 kilograms is 10 meters above the ground? Well, this is simply the gravitational potential energy. At this point, our velocity is 0, so there is no kinetic energy. It's only potential energy in the form of gravitational potential. So, potential energy is equal to mgh. In this case, our m is 1.2 kilograms, our g is 9.81 meters per second squared, and our h is 10 meters high. We plug those numbers in, and we find our energy in joules is 117.72 joules of energy at the initial position. At the final position, when our object bounces back to a distance of 7 meters high, we simply use the same formula, but now instead of using 10 meters, we use 7 meters. We plug that in, and we find that our amount of joules of energy at the final position is 82.44 joules. So note that these two guys are not equal. The second guy is less. The final amount of energy is less. And that makes sense because some amount of energy, in fact the difference between the two, went into increasing the internal energy of our ground as well as of the object. So now let's take the difference. How much change in energy do we have? Well, change in energy is equal to the final minus initial, so 82.44 joules minus 117.72 joules, and we get negative 35.316 joules. Now, the negative simply comes from the fact that our object was the system that lost energy. This energy was transferred into the ground, and this is the amount of energy that was transferred. 35.316 joules was transferred into the ground, increasing the thermal energy or the internal energy of the ground.